Video. Today we're going to be continuing with parametric equations, and we're going to start off with start our episode off with a question, which asks, we are given this graph, this kind of parametric curve, which looks kind of like a fish, like this. And this is composed of x equals t squared and y equals t cubed minus t cubed minus 2t. Okay, and the first thing we need to do is find the point of intersection here. And then second thing is find tangent line. Find the tangent line. Find the tangent line at that place. And so I want to illustrate kind of the thinking steps we want to go through. So if you imagine this is like a particle, let's think of it like an insect, right? A little ladybug. It goes down like this, then it loops around, and then it travels down this way. So it crosses the same point in two different times. Therefore, there's going to be a time 1 when it crosses this first, and there's going to be a time 2. And the question demands that time 1 is not equal to time 2. So how are we going to do this? How do we find the intersection? What we have to realize is that this point is where y and x at two different times aligns perfectly. If you imagine, we have x and y for time 1, and then x and y again for time 2. And even though time 2 are not same, x and y is the same. So let's rewrite the equations. Let's say that we're going to say that x at time 1 is equal to x at time 2, right? And we can also say that this is also equal to time, because x is equal to time squared, t squared. It's t1 squared equals t2 squared. That's really nice. And then we can also say y1 is equal to y2. That means that t cubed, t1 cubed minus 2 times t1 is equal to t2 cubed minus 2 times t2. And let's solve using the left equation here. We can get t1 squared. Let's square root both sides. So t1, the square root of t1 is going to be equal to the plus minus square root of t squared, t2. And now we can either have t1 is equal to t2, or t1 is equal to minus t2. Since t1 cannot be equal to t2, you can't have one time equal to the second time. It just doesn't work. Therefore, t1 has to be equal to negative t2 by virtue of it being different. So now we can plug that into back here. Let's plug this back in here. I'll use a different color. Then we can say that every t1 we sub in minus t2 cubed minus 2 times t2 is equal to t2 cubed minus 2t2 minus t2. Okay, and this minus comes out to make it positive. This cubed is going to be minus t2 cubed plus 2t2 is equal to t2 cubed minus 2t2. And now let's move everything to one side. This is going to be 0 is equal to 2t2 cubed minus 4t2. And now we just need to factorize. This is going to be equal to 2t2 out of t2 squared minus 1. No, that's not true. I need a bit more space here. Let's take 2t2 out. 2t2 out gets t2 squared minus 2. And then that's the difference of 2 squares. So it's t2. And then this is t2 minus root 2 and t2 plus root 2. Then this gives us t2 is equal to 0, is equal to root 2, or is equal to minus root 2. Okay. T2, let's think about this. If T2 was equal to 0 and T1 is equal to minus T2, then therefore T1 would also be equal to 0. But remember the condition that t1 cannot be t2. Because if we use 0, t1 will be equal to 0, the same as t2. Therefore, it cannot be 0, because then those two will be the same. This leaves us with root 2 and minus root 2, which is the same idea as saying t2 is equal to root 2, and therefore t1 is equal to minus root 2. Or you can take the other way around. T2 is equal to minus root 2. T1, because it's negative of T2, would be equal to root 2. So this is fine. We can take any of those as T2, and the other would be T1. So now that we know what T1 and T2 is, T1 is root 2. Let's take minus root 2, because minus happened first. Minus root 2 and root 2, then we just have to find the point and the tangent line for each one. So let's say t1 equals minus root 2 first. Then x would be equal to t squared, so would be equal to 2. X would be equal to 2. Y is t cubed minus 2t. T cubed minus 2t. And so that would be equal to minus cube root of root 2, cube root of root 2 minus 2 root 2. Sorry, minus 2 root 2, but it's already a minus, so it's plus. So then we have the point x equals 2, and minus cube root of root 2 plus 2 root 2. This, you can think of this as 2 root 2 squared times root 2, right? Because root 2 squared is 2. This is actually just the same thing as root 2 cubed. So we have minus root 2 cubed plus root 2 cubed gives us 0. So that it's the point 2, 0. And we have, let's find the gradient straight away as well. So dy over dx is equal to dy over dt over dx over dt. Therefore, dy over dt, let's dy over dt this, so that's 3t squared minus 2 over dx over dt, which is 2t. And the gradient would simply be t is minus, so it's 3 times minus root 2 squared is just 2, that's 6. Minus 2 is 4 on top. And this is minus 2 times root 2, minus 2 root 2. So that would be minus 2 over root 2. And if we think about it, that's just minus 2. Let's rationalize this. Minus 2 root 2 over 2. These two cancel out. It's just minus root 2. So that's the gradient. And now if you remember from our previous lesson, the tangent line we can just write as y minus the y coordinate, which is 0, equals to the gradient, which is minus root 2, multiplied by x minus the x coordinate, which is 2. Hey, AJ. So the tangent line equation at this point would be equal to y minus 0 equals minus 2 times x minus 2. Okay, and we're going to do the same steps for t2, the second time it came over, which is root 2. So x equals t squared, x would just be root 2. Y would be equal to t cubed minus 2t, so that's just root 2 cubed minus 2 times root 2, which we've established this is also equal to root 2 cubed, so this would also be equal to 0. Kind of given because we are talking about the same point, right? It's crossing the same point, so we are expecting the same coordinates. Sorry, not root 2 here. T squared, root 2 squared is 2. 2, 0 here. And so now we just need to find the gradient. For this one, the gradient would be equal to y minus 0. And remember, dy over dx is equal to dy over dt over dx over dt, which is equal to 3t squared plus 2 minus 2 over 2t. So this would be equal to, again, t squared, root 2 squared is 2, 3 times 2 is 6, 6 minus 2 is 4 over 2 root 2. Same form as before, we do the same steps. That's going to leave us with m equals root 2, because this is positive, the other one's negative. And so y equals, gradient is root 2 multiplied by x minus the previous x. So it's going to be x minus 2. There we go. So yeah. So at the point 2, 0, so there's two tangent lines, which is pretty obvious if we think about the thing, right? Because one is going down, and the every time it loops down, there's another time it's going down. So those are the two lines that we found. The first line is y minus 0 equals minus root 2 times x minus 2, and the second tangent line is y minus 0 equals root 2 times x minus 2. All right, thank you guys so much for watching.